is we're going to solve systems of equations where those equations are conic sections. Or there are going to be some instances where we have one linear equation and the other equation is a conic section. So for example, we could have like a horizontal ellipse with a line cutting through it thusly. We want to find out what's dat and what's dat. So here, we'll do this problem two ways, algebraically and then in the calculator. Algebraically, what we want to do to begin this process, I want to use elimination. And the way I'm going to go about using elimination here, I'm going to multiply this top equation by 9. If I do that, then I get 9x squared minus 9y squared equals 81. Bottom equation is x squared plus 9y squared is 169. Then I take these two equations, add them together, so I get 10x squared equals what? 250. So x squared is 25. So what is x? It's going to be plus or minus 5. But we have to keep in mind here, we now know that x is plus or minus 5, but what are we trying to figure out when we solve a system like this? The points at which these two graphs intersect. So we now know that the x could be 5, the x could be negative 5. So I'm going to plug back into this original equation, x squared minus y squared equals 9. And I'm going to have to plug in twice, once with 5, once with negative 5. So I've got 5 squared minus y squared is 9. So 25 minus y squared is 9. So 16 is y squared, meaning y could be plus or minus 4. So our solutions are all 4 of them.
It's frozen.
Are you going to have to unfreeze that or do something? I can't see it.
Ding. Does it make sense that we would have 4 intersection points? What two conic sections are we dealing with here and here? This one is a... So let's graph these to see what it looks like. How do I have to adjust these to put them in the calculator? I have to solve them for y. So we get x squared minus 9 is y squared, so y is plus or minus the square root of x squared minus 9. Then we get that 9y squared is 169 minus x squared, so y is plus or minus the square root of 169 minus x squared all over 9. So in our calculator, we're going to have to put in 4 equations. So for this one, for example, we're going to have to make y1 the square root of x squared minus 9. y2 will be the negative square root of x squared minus 9, and so on. We have this. You go to y equals, so we have the square root of x squared minus 9. We have the negative square root of x squared minus 9. For the other one, we're going to have the square root of 169 minus x squared over 9, and the negative square root of 169 minus x squared over 9. Noticing that I do have to put the numerator in parentheses there. So make sure you do that anytime you're graphing any sort of rational expression. So we do all of this, and then we'll have to find a zoom window to work. Let's try zoom 0, which is zoom fit. Let's see what the calculator gives us for zoom fit. Ding, 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 ding. So, we know that we don't have the full picture of the ellipse, correct?
Yes, sir.
We're missing these ends. But we see the 4 intersection points, right? So second, calculate intersection. When you calculate the intersections, things can get a little bit dicey
All is really life.
because we have 4 points that we need to find. We have 4 graphs that we need to find the intersection of. So up in the top left corner, you can see it's asking for the first one, square root of x squared minus 9. And that is the graph here. So push enter on the first curve. So we scroll over. So we're on first curve, and you scroll until you can see the cursor. You push enter. Second curve, we want to be on the ellipse. So you see the cursor is on the ellipse now. Push enter and guess. So the first point is -5, -4. And to move from graph to graph with your cursor, you push up or down. So to do this process one more time, calculate the intersection. What is our first curve? I'm going to scroll over. I'm going to be looking for this intersection here. So scroll over until the cursor is there. We can see I'm on the hyperbola. Push enter. Now, I want to know where it intersects the top half of the ellipse. See that my cursor is not there, so push down. So that took me to my third equation that I typed in, y3. Push enter and guess. So we get 5, 4. And then you just repeat that process for the bottom 2. To graph this in the calculator, this equation's already good to go. Don't need to change it. This one you need to solve for y. So we get y squared is 36 minus x squared. Take the square root of both sides, you get y is plus or minus the square root of 36 minus x squared. So the 3 things we put in the calculator, y1 needs to be the square root of 36 minus x squared. y2 is negative square root of 36 minus x squared. And y3 is x minus 2 squared minus 3. Does it matter which one's y1, y2, y3? No. All that matters is that you definitely have this one, you definitely have this one, and you definitely have this one in one of those 3 spots. So then you graph it. I'm going to put these equations in like this. And then you are going to do zoom, square. You get a circle and a parabola, like that. Second, calculate the intersection. Both intersection points happen on the positive part. So you need to understand when you did the square root. This is the positive square root that we graphed. This is the negative square root that we graphed. So both intersection points are the positive square root in the parabola. So there's my first curve. Second curve, the cursor's down here. I don't want that, push down. So now the cursor's on the parabola. Push enter and then guess. I want that intersection. So it is 4.614, 3.835. Then we want to calculate the other intersection. First curve, positive square root. Second curve, not there. We want to be on the parabola again. Push enter. And then when it says guess, get the cursor over to the second intersection point. Negative 0.986, positive 5.918.